Dear students, I, Mr. Vishal Shaha, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. In this video, we are going to discuss about the different methods that are used for expression of concentration. In this video, we will see what is the meaning of concentration, and there are different ways by which we can express or we can put up this concentration values of a different solutions. In previous videos, we have covered with the different types of instrumental methods, including the different classical methods as well as the different instrumental methods which are used for the analysis of different substances. If you have not watched my previous videos, you can watch, and if you like the content of this my channel, then you can subscribe to my YouTube channel. Now let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session. After this session, students will be able to explain different terms that are used for expressing the concentration phenomenon. Now, before starting with the terms that are used for the expression of concentration, we will see few terms. First term that we are going to discuss is a solution. Now, what is the meaning of solution? It is a homogeneous mixture composed of two or more substances. In such a mixture, solute is dissolved in another substance that is known as solvent. Basically, solution is consisting of two parts, you can say, or two terms. One is the solute, other one is the solvent. For example, if we take the sodium chloride, or you can say salt, and if you add into the water, initially you can easily see the NaCl that is present in the water, but after some time it gets dissolved. Here, whatever the salt that we have used, that salt is nothing but the solute, and water is nothing but the solvent. Means after the dissolution, you are not able to see the particles of the sodium chloride, so that that mixture becomes homogeneous. That's why solution is known as, it is a homogeneous mixture which is composed of two or more substances. Now generally in such a mixture, solute is dissolved in another substance which is known as the solvent. Similarly, we can take the example of the sugar. If we add sugar into the water in a different limits, then that sugar is also gets dissolved into the water. So this is the meaning of the solution. Now concentration. What is the meaning of concentration? It is a measure of how much of given substance is present or mixed with the another substance. Means amount of solute. Suppose if I take 1 gram of a salt and if I add into 10 ml of water, similarly I can take 2 gram. So there is a different amount of solute is present in the same quantity of water. So it is necessary to measure the how much amount of solute is present in that solvent. So that is expressed in terms of the concentration. That is nothing but the concentration. So it is a measure of how much given amount of solute there present in the another substance. Here it corresponds to the solvent. So in this way, the concentration can be measured for the different solute particles. Most frequently, the concept is limited to homogeneous solution. Remember, here this concentration term is limited, or that concept is limited to the homogeneous solution. Already we have discussed what is the meaning of homogeneous solution. When a solute is completely dissolved into the solvent, that type of solution is known as the homogeneous solution, where it refers to the amount of solute in a substance. So these terms are applicable to the homogeneous solutions. So these are the various terms. Now we are familiar with the solution, what is the meaning of solution, as well as the what is the meaning of concentration. Now there are different ways are there by which we can express these concentrations. Few of the terms you may know, like normality, molarity. So there are few other terms are there that we are going to discuss in this particular video. Now, there are different types of solutions can be used. One is standard solution. Now, standard solution is a chemical term which describes a solution of known concentration. As I said in previous slide, suppose I take 1 gram of salt and if I add into 10 ml of water, in that case I know how much amount of solute is present in that solvent. So when you know the concentration of that particular solution, that type of solution is known as standard solution. The concentration of solution is normally expressed in units of moles per liter. Now, what is the meaning of moles? I will later tell you. So, generally standard solution, concentration of standard solution is expressed in moles per liter. Now, standard solutions are normally used in titrations to determine the concentration of substance in the solution. So, they are used to determine the concentration of other substances that are present in the solution. So, that is the importance of the standard solution, because we know the concentration of standard solutions. Now, first term that is used for expression of the concentration is percent concentration. Now, what is this percent concentration? Many times a concentration is expressed in terms of parts per 100. And it can be expressed as percent weight by weight. Now, what is the meaning of percent weight by weight? Here, it can be expressed as mass of a solute divided by mass of solution into 100. As we are going to multiply this ratio with the help of the 100, that's why these concentrations are nothing but the percent concentration. Means, what is the meaning? Suppose I want to prepare 5% NaCl salt weight by weight. Here, weight by weight refers to the mass of solute as well as the mass of solution. Means, if I take 5 grams of salt and if I dissolve it in the 10 gram of solvent, 10 gram of solvent, that is nothing but the water, and into 100, so that will be the concentration that is expressed in terms of the percent weight by weight. Here, now the question may arise in your mind that how we are going to take the mass of a solution or the solvent, because generally we are going to measure the volume of that particular solvent or the solution. Here, just we have to weight that particular solution, or with the help of the density we are going to calculate the mass of that solution with the help of the volume, because we know formula that density is equal to mass upon volume. So with the help of this we can calculate the mass of that solution. So this is the first term that is used for the expression of the concentration in percent, is percent weight by weight. Then percent weight by volume. Here you can see, just here we have replaced this W with the help of the V. Here V represents the volume. So percent weight by volume means what? Mass of a solute. Now here you can see solute is taken in the mass only, and the whatever this volume is there, mass of a solute divided by volume of solution into 100. So here the mass of solution is replaced by volume of solution. Means 5 gram of a solute that is taken into 10 ml of solvent into 100. That is nothing but the percent weight by volume. If you check the label of different branded marketed drugs that are present in the market, you can observe these terms. For example, in suspension you will see either W by V, W by W, or another term is there V by V, where it represents the concentration in terms of the percentage. The last percent term that is used for the expression of concentration is percent volume by volume, where both solute as well as the solvent or solution are present in the form of the volume. So volume of a solute divided by volume of solution into the 100. So it expresses the percent concentration in terms of the percent concentration. So here these two terms are there: percent weight by weight, percent weight by volume, and percent volume by volume. So this is about the percent concentration. Sometimes concentrations are also expressed in terms of parts per million, that is the ppm. This is the useful for the solute which are having very minute quantities. It is frequently employed to express the concentration of very dilute solutions and is expressed as ppm. Now, how to calculate the ppm concentration? Mass of a solute divided by mass of a solution, that is the weight by weight, into, instead of 100, we are going to use the 1 million term, that is the 10 raised to 6. That's why here this is expressed in terms of parts per million. Just instead of percent, here as we are going to use million term, we have to multiply it with the help of the 10 raised to 6. Then another term that is used for the expression of concentration is parts per billion. Now million is replaced by the billion. That's why this term is basically used for the extremely dilute solution as compared to the ppm also, and it is expressed as ppb. ppb, that is equal to mass of a solute upon mass of a solution. Now here 10 raised to 6 is replaced by 10 raised to 9. So here these are the various ways by which we can express the concentration by using ppm, that is the parts per million, and parts per billion. Now the next term that is used for the expression of concentration is molar solution. Now it is the one that contains 1 mole of a solute per liter of a solution. So molar solution is defined as number of moles of a solute per 1000 ml or per liter of the solvent. It is expressed or it is indicated by using the capital M. The molarity can be calculated as M, that is equal to the molecular weight of that particular solute divided by the 1000 ml or the 1 liter. Generally 1000 ml is used to express that particular volume of the solvent. Now we will see few examples how we are going to prepare the molar solution of different analytes. Suppose a 2 molar solution of aqueous sodium hydroxide. Now we know what is the formula of sodium hydroxide. Here NaOH. Now you are maybe familiar with the how to calculate the molecular weight of that particular substance. You may have studied it into your HSC. Now sodium is having 23, oxygen is having 16, hydrogen is having 1. So if we calculate the molecular weight of that particular substance, it becomes the 40. So suppose I want to prepare 2 molar solution of sodium hydroxide, then which is written as 2M, that is the capital M, NaOH. That means 2 moles of NaOH per liter of the solution. So how to calculate the 2 moles? 1 mole of NaOH is nothing but the 40 grams. And if I want to calculate 2 moles, then 40 into 2, that is equal to 80 grams. So if I take 80 gram of sodium hydroxide and if I dissolve it 1 liter into the solvent, then it becomes the, or 1 liter of solution, then it becomes the 2 molar NaOH solution. If 1 liter of solution contains 98 gram of H2SO4, this means that concentration is 1 mole or 1 molar. How? Because if we calculate the molecular weight of this H2SO4, it becomes 98. So if I take 98 gram of H2SO4 and if I dissolve it into 1 liter of a solution, then it becomes 1 mole solution of H2SO4. In 1 liter of solution containing the 196 gram of H2SO4, this indicates the concentration of that solution is 2 molar. In this way, we can calculate the moles of that different solvent. Thank you.